Start that, okay? All right, this is not in standard form yet. Why is it not in standard form?
3x.
Yes, what you have to do, you have to factor out that 3 from those parentheses. Okay? So what does that factor to? This becomes what? Let's do it in green. Y equals -1/2 cosine. When I pull that 3 out, it's going to be 3 times x. Yeah, factoring is dividing. So I take my pi and I divide it by what I pulled out of the parentheses. So pi divided by 3 minus 1. Minus 1 right there, okay? All right, guys, can we keep it down a little bit just for this problem? Thank you. All right, and then I just realized you can do this problem. The best way to do this is to work from right. So I'm going to erase the original problem just to make more space. The best way to do this problem, to graph this, is to work from right to left. Okay? So first, let's take a look. Let's first take a look at that -1, that first number on the right. What is that going to do? What's that -1 on the right going to give me? Vertical shift down 1, right? So I have the parent graph drawn right here, right? Do you guys see how it's drawn with y equals 0 straight through the middle? Since I'm having a vertical shift of -1, where do I need to draw my new graph around? I'm going to draw around y equals -1. Okay. So that's going to be the line that I draw my squiggly around, okay? Good. Vertical shift, taken care of. Let's go to that next number. Plus pi over 3. What's a plus pi over 3 going to do to my graph? Left shift by pi over 3. It's going to give me a left shift by pi over 3. So what's going to happen then is my first point, I'll draw this graph. What's a good color? I'll do blue. So cosine starts where? At the top, right? But what is that negative going to do? So I'm going to start at the bottom. Yep. So I'm going to start at the bottom, and it's shifted to the left a little bit. So I don't know I haven't talked about the amplitude of this curve, but what's the x-coordinate of that first point on the bottom going to be? Negative pi over 3. Yep. Okay. I can draw my squiggly at this point, right? It's going to look just like this pink dashed curve, except it's going to be upside down. It's going to look like a hump. So, okay. All right. Let's look at keep going to the left. Keep going to the left. The next number, that 3. What does that 3 tell me? The number that's right in front of cos. Is that?
2 pi.
Yeah. So this is going to tell me that my period is what?
6 pi.
2 pi divided by that number. So the period is 2 pi over 3. So let's look at this last point. Let's start with the first and last points. Okay? What's the x-coordinate of this last point going to be? If I start at minus pi over 3 and I go to the right by 2 pi over 3, what's that? How do I find that x-coordinate? Minus pi over 3 plus 2 pi over 3, right? We don't like pi, right? So I can just add it as -1/3 plus 2/3, which is just 1/3, right? So my coordinate's going to be pi over 3. I can put the pi back on. Okay. Right? This point here at my peak, right? At my peak. That x-coordinate is going to be smack dab in the middle of minus pi over 3 and pi over 3, right? So what's that x-coordinate going to be? Smack dab between minus pi over 3 and pi over 3. 0. Okay, that's my x-coordinate. And then these 2 points right here. This first one here. Smack dab between minus pi over 3 and 0. What's that? How can I figure that out? How do I find a number that's right in between two numbers? Atom divided by 2. So negative 1/3 plus 0 divided by 2. That's the same thing as negative 1/3 times 1/2, or negative 1/6. So this is going to be negative pi over 6. Yeah. Default, period, yeah. This point right here, smack dab between 0 and pi over 3. Positive pi over 6, okay? Now I can start filling in my y values. Okay? Let's keep going to the left. Let's highlight this next number. What's my amplitude going to be? My amplitude is what? 1/2, okay? So your y-coordinates in general, they're going to equal your vertical shift, your vs, plus or minus your amplitude. So here it's going to be -1 plus or minus 1/2. Okay? So this point here at the top, what's its y-coordinate going to be? -1 plus 1/2. What's -1 plus 1/2? It's going to be -2/2 plus positive 1/2. It's going to be -1/2. Okay. These two right here in the middle, what line are they on? Yep, so the y-coordinate of -1. And then these two guys here at the bottom, what are their y-coordinates going to be? It's going to be what? -1 minus 1/2. What's -1 minus 1/2? Yep, -3/2. Good job. All right, so I think we're following. We just got to learn how a good way to do that on our own, okay? So that's my graph. 0, right here. This point is smack dab between my left and my right endpoints. Smack dab between minus pi over 3 and pi over 3. How can you find that? Atom and divide by 0, right?
Mr. Rushka, how do I do a problem like number 3 again?
How many radians are in 8.215 rotations of a wheel? Yeah, so you actually don't need to know like the radius of the wheel. Okay, if you're going 8.25 times around the wheel, how many radians is that? Any idea?
So multiply, is that like essentially like degrees multiply it?
Yeah, so how many radians are in one rotation of the wheel?
1?
How many degrees are in one rotation of the wheel?
360.
360. Can you convert that to radians?
So we would do
360.
this times 360?
Yeah, well, okay, so the best way to do it is you want to convert to radians first. So convert 360 degrees to radians. That's how many radians are in one turn of the wheel. Oh, sorry, let me stop recording. Thank you guys for your cooperation.